A group of engineers at Hermeus in Atlanta, Georgia, are making a test plane that can fly itself and can go faster than 3,000 miles per hour. The team's ultimate goal is to make passenger planes go 6 times faster than they do now. The Quarterhorse, which is Hermeus's first demonstrator aircraft, is a small, single-engine autonomous vehicle designed to do 2 main things: briefly touch Mach 5 to collect data and test their Chimera engine. In the development program, they are not just building one Quarterhorse, they are building 3. So this lets them take risks during flight tests that would not be possible otherwise. Hypersonic flight isn't something new. The X-15 came before spaceships and planes of today and tomorrow. When you look at how these planes are dropped in midair, you can see that they are powered by rockets. For the last 50 years, that's how we've been able to go faster than sound. Hermeus, on the other hand, is trying to do something different. They are trying to build an airplane that can take off from sea level, reach hypersonic speeds, land, and be used again, all while only using one jet engine. The way a plane is usually made to take off and land, and the engine it needs to do that is on the opposite end of the spectrum from the best high-speed plane. Engineers are pulled in different directions by these different kinds of limits. So, they will have to make some design trade-offs to make a single set of hardware that can take off, break the sound barrier, and speed up quickly. A high-speed plane like the X-15 has a wing designed to reduce drag at higher speeds, but at lower speeds, the same features aren't good because they reduce lift. The hard part about building the real Quarterhorse vehicle is making it as small as possible while still proving that it can reach Mach 5. Anything that goes faster than the speed of sound, called Mach 1, and about 760 miles per hour at sea level, is called supersonic flight. Hypersonic flight means going faster than 5.5 times the speed of sound, which is about 3,800 miles per hour at sea level. A typical commercial jet can take people from New York to Los Angeles at about 500 miles per hour. Heat is one of the unique problems with going really fast, but Hermeus wants to make a hypersonic vehicle that can be used more than once. Their plan is to use materials that heat up quickly so they can make what is called a hot structure. To protect the space shuttle's substructure from the high temperatures of re-entry, it will be covered with ceramic tiles that can be broken and replaced. Since there is no air in space, a spacecraft may accelerate without air friction. However, as speed increases within the Earth's atmosphere, air friction causes the aircraft's surface to heat up. According to the team, Quarterhorse will be a bad subsonic aircraft, and it will also be a poor hypersonic aircraft, but its purpose is to bridge that gap so that we can collect the necessary data to develop a truly good hypersonic aircraft with Dark Horse in the future. Building a hypersonic-capable engine may be the most difficult of the hurdles associated with traveling from zero to hypersonic. On a normal aircraft, the engine hangs from the underside of the wing. In contrast, the entire aircraft of this Mach 5 prototype is wrapped around the engine. A conventional jet engine generates thrust by compressing air, adding fuel, igniting the resulting mixture, and accelerating it via a nozzle. A different form of a jet, known as a ramjet, is required at higher speeds. They are extremely basic devices. From a thermodynamic standpoint, they operate identically to conventional jet engines in that they compress air, burn it, and expel it through a nozzle. Instead of a mechanical compressor, such as those found in jet engines, this system uses a natural compression mechanism known as a shock wave. When a plane goes faster than the speed of sound through the air waves in front of it pile up, making what is called a shock wave. Shock waves naturally compress the supersonic airflow inside a ramjet, so there is no need for a mechanical compressor. So, there's just an intake that naturally squeezes the air and a combustor where fuel is put into the flow and burned. The Quarterhorse moves forward by breathing, which is the whole length of the vehicle. It goes all the way from the front of the plane, where the intake is, to the back, where the nozzle is. Given that Hermeus aircraft will take off and land on the ground, their engine must operate as a regular jet engine and switch to ramjet mode just once at higher speeds. The challenge with ramjets is that they don't work until a craft is flying at Mach 2 or above, and they don't become truly effective until Mach 3. So, jet engines typically operate up to roughly Mach 2. Hermeus says that all of the parts of the technology they need have been around for decades. The hard part is getting them all to work together. They are employing a strategy that is basically based on engineering rather than science. According to them, neither new materials nor new propulsion technologies are being developed. No doubt, it takes years to build one of these. The team can take a commercial jet engine, take off its afterburner, put on its own afterburner, and run it way higher and faster than it was meant to. As the name suggests, an afterburner is at the end of a jet. It adds more fuel to the exhaust from the jet and lights it. This gives the jet more thrust and lets the plane go faster. Switching from a turbojet engine at low speed to a ramjet engine at high speed has never been done in flights, so the team will do it first in a wind tunnel on the ground and then with Quarterhorse in the air. That's a big risk. The Chimera engine powers the Quarterhorse and is meant to function at altitudes of 80 to 90,000 feet at Mach 4 to 5 speeds. Hermeus has successfully tested their Chimera engine over 100 times, including late last year for elected authorities. A jet must continuously burn new air as it passes by. This necessitates a constant flame. The flame holder, thrown from the back of the Chimera, is a component within the engine that prevents the flame from extinguishing. Hermeus says that one thing that makes their approach different is that they use a process called vertical integration that is based on what private space companies do. Hypersonic planes are very tightly connected systems. One small change can have a big effect on how the car works or what the power system has to do. It's hard to design each part separately and then put them all together. Everything has to be designed at the same time. Vertical integration makes it possible to trade across the points where these systems meet, not just at the beginning when there isn't much known about it, but as it grows and takes off. If Hermeus can pull this off and build their Halcyon plane for 20 people, you might wonder what it will be like to fly at very high speeds. Because it's so hot outside the plane, there won't be any windows. Instead, high-resolution camera feeds will be shown on LED screens on the cabin's walls. These feeds will show the shape of the Earth and some of the darkness of space. That's it on the Mach 5 engine. What do you think? Will this be a success? Let us know your thoughts and considerations in the comment section below. If this video is insightful, please go on and like this video. Remember to subscribe to our channel and click on the bell button for more updates.